A good day to all of you. Let me introduce myself. My name is Dr. Subha. I work as an assistant professor in the Department of Chemistry, RMD Engineering College. I'm very happy to share with you a video lecture on the topic municipal water treatment. Dear students, this topic will be of great practical utility to all of you because we are going to explore into how water is being treated, how we are using it, and how domestically it is made available. So let us move into this video lecture. Let me try to first of all talk to you on what is called water for industrial use. So when we think about water that is being used in daily life, we need treating it, and that is very important, is it not? So any technology or any process that improves the quality of water by plainly removing the contaminants and all the undesirable components present in water and making it fit for drinking or industrial water supply or irrigation or probably a river flow maintenance is what is called as water technology. Now, talking in terms of boiler feed water, okay, as most of the industries are using water for its treatment and water for its practical applications, we need to use boiler feed water free from all the contaminants that can be present in it. So, we should know about what are the requirements of boiler feed water. So, it should be free from calcium and magnesium ions. The hardness should be less than about 0.2 ppm. The water should be free from dissolved gases like oxygen, carbon dioxide, etc. It should also be free from suspended impurities. It should be free from dissolved salts. The caustic alkalinity should be somewhere between 0.15 ppm and 0.45 ppm. The soda alkalinity should lie somewhere between 0.45 ppm and 1 ppm. Of course, it should be free from both oil, turbidity, grease, and all other contaminants that make it unfit for use. Now, we were talking about how water can be treated for a boiler for industries. Now, let us target on how water need to be treated municipally or how water is being treated for domestic purpose. So, water treatment processes include a number of steps. It is very interesting to note down that there are a frequent set of methods that are commercially employed to clear water out of its impurities. So the basic idea is to remove all the contaminants from water. Treatment involves physical, chemical, and biological processes. The most common treatment processes in potable water treatment are chemical and physical processes. Now, students, let us go stepwise and try to explain and understand how to remove suspended matter from water. So there are several steps as already explained. We shall move on stepwise and move into a detailed fashion and talk about how water is being treated. The first method is called screening. Screening involves treating raw water that can be passed through screens that contain large number of holes. With any kind of floating matter that includes paper, that includes fishes, that include dry leaves, or maybe wet and organic matter. So anything gets removed in this method. So the first step involves removing all the macro objects. The second step is called sedimentation. And under sedimentation, we are going to talk about sedimentation that moves on along with coagulation. So when we talk about sedimentation involved with coagulation, we give priority to talking about the suspended impurities presented in water. Suspended impurities can be removed by allowing the water to simply stand undisturbed. You can leave it to stand for about few hours, maybe some 2 to 8 hours of time. Allow it to settle down in big tanks. The tanks may be of 5 meters depth. Okay, because of the forces of gravity, most of the particles will slowly settle down to the bottom of the tank. More than 70 to 75% of all the suspended matter can be removed by this technique. Of course, plain sedimentation cannot remove all the impurities in water. All the finely divided silica, the clay, the organic matter, everything cannot be removed. So we need to employ some other technique to try treating water. You see a flow diagram there that talks about the preliminary treatment, the primary treatment, the secondary treatment, and the tertiary treatment in treating water. So, apart from allowing water to settle down for some time, we need to do something to make water get purified and make it get clear out of its impurities. So we adopt a technique called coagulation. So sedimentation with coagulation is a process of removing the particles present in water by addition of certain chemicals called coagulants before sedimentation. So there are a number of coagulants that can be practically employed. A few coagulants I've mentioned here. Number one, it can be alum, or number two, it can be sodium aluminate. So you see the formula for aluminum sulfate there. So we are treating it along with water. So this converts it into a product called aluminum hydroxide. Your aluminum hydroxide can act as a flocculant because it has large surface area. It removes all the impurities present in water by neutralizing the charge or by adsorption or by mechanical treatment. So generally, whenever we have coagulants, they are added in solution form. So you can use a mechanical flocculator for thorough agitation and then you can add it inside water. Substantial reduction of bacteria also takes place during this process because the oxygen released by some of the coagulants destroys the bacteria, breaks up some of the organic compounds, partially removes the color, taste, and also the other bacteria that causes impurities and maybe bad odor and maybe color to water. Okay. So third step is called filtration. Filtration is something that we employ even at home. Is it not, students? Suppose we want to filter water at home. What do? We simply employ techniques like boiling. So this we have commonly discussed as a method for removing hardness in water. We call it as temporary hardness. So maybe we get reminded of this here. So filtration, you must be seeing water getting filtered on its own under the earth's surface. Okay. Whenever we have, just imagine some road is being excavated for some kind of a maybe some beneficial activity, maybe some road construction is going on. When you open out the soil, you can find out layers of sand, gravel, coarse sand, etc., packed naturally on its own. So as you go inside, water gets pure. Okay, this is because of the natural tendency of water getting filtered on its own. So this is a third technique and this is called filtration. It is a process of clarification of water by passing the water through a porous material. It is capable of retaining all the coarse impurities on its surface and on the pores. So porous material that can be used can be a filtering media. And the picture here you see is a typical example for a sand filter. So the equipment is called a filter. So we will talk about the commonly used materials as filtering media. Number one, it can be quartz sand. Number two, it can be crushed anthracite. Number three, it can be porous clay. So slow sand filtration, though it takes time, is generally the best method that can be employed in municipal water treatment. You can see the process there. You can see a typical sand filter. It consists of a tank. It has a bed that contains fine sand. It is made up of top layer. Okay. And then you have coarse sand followed by coarse gravel at the bottom layer. It is provided with an inlet for sedimented water and under drain channel at the bottom for exit of filtered water. So the sedimented water will get distributed uniformly over the bed. It flows down slowly through the various layers and finally comes out as pure water. So the rate of filtration becomes slow sometimes. This may be because of the retention of impurities present in the pores. So what do? Like how we do regeneration in the case of demineralization. Here, top layer of sand that can be sedimented or can be deposited can be replaced. Okay, you can simply scrape it down, you can clean it out, and you can increase the efficiency of the process. Now, let us continue talking about removal of microorganisms. So, removal of microorganisms can be best done by a process called disinfection. So, disinfection, just now we were talking about a process called boiling. So, removal of pathogens, disease-causing microorganisms is called as disinfection. So, boiling simply puts the microorganisms present in water. So when you keep boiling water for a long time, the harmful bacteria and the viruses cannot survive the temperature. So this process is applicable only for household or other simple processes. Definitely a municipality cannot employ this method for clearing water out of its impurities or killing out the microorganisms present in water. So we need to go for better methods. Probably add bleaching powder. That is the second method. So the formula for bleaching powder, what is it, students? It is CaOCl2. When you add it to water, it converts to calcium hydroxide and chlorine. The chlorine, when added to water, okay, makes or produces hypochlorous acid. So this hypochlorous acid, by the formula HOCl, is responsible for killing germs. So when bleaching powder is added to water, first chlorine is liberated along with calcium hydroxide. The chlorine then reacts with water. It forms HCl and HOCl. HOCl is a germicide. It can kill bacteria or all the germs present in water. Now, what are the limitations of adding bleaching powder? All of us know how bleaching powder water tastes, is it not? Sometimes we drink chlorinated water. We know how it is. Okay. So the limitations, sometimes it is really difficult to store. It is very unstable. And then it introduces calcium in water, which increases the hardness. So we've been striving too hard to remove the hardness in water. By adding bleaching powder to water, in spite of it being unstable, we are also able to understand that calcium is unnecessarily being introduced into the water system. So what can we do next? We will try the third method of adding chlorine. So addition of chlorine can be called as chlorination. So disinfection can be done by adding liquid chlorine or gaseous chlorine to water. So chlorine produces hypochlorous acid, which will kill all the microorganisms. Now look at that. Chlorine will add on to water and will produce HCl and HOCl. Of course, HOCl is responsible for killing the germs present in water. It dissociates to form H plus ions and OCl minus ions. So it is found out that HOCl will cause both death of microorganisms, okay, both bacteria and viruses. Chlorine is a very good disinfectant and it can operate at a pH of about 6.5. So chlorination can depend upon what are the factors? It can depend upon the most important point being time of contact. So the number of microorganisms destroyed by chlorine per unit time is proportional to the number of microorganisms that remain alive. So death rate starts become a maximum, okay, at the starting point. So this is about chlorination. So in our video lecture today, we were talking about a number of factors that include filtration, sedimentation. We were also talking about disinfection methods. We were talking about disinfection. We were talking about how boiling or adding bleaching powder or chlorine can be involved. We were talking about the practical difficulties, the disadvantages, etc. Is it not? Now, I think we need time to move on to the video lecture next and continue talking about how this actually works out, what is called breakpoint chlorination, how much chlorine must be actually added, etc. So thank you for your patient listening. We shall continue again with the next video lecture on part 2, municipal water treatment. Thank you for your patient listening. Thank you, students.